Hello everybody. So this is section 1.3 and we're going to solve some linear equations. I'll show you a couple cartoons first. Maybe they're funny to you, maybe not. Maybe you've seen them a million times. Maybe you haven't, but um, just show them to you here at first anyway. So he's saying just a darn minute. Yesterday you said that x equals 2 and now it equals 3. Um, that's one of the big ideas here is that just because we usually use x just because we always have. I mean, sometimes people just do things because they've always done it, which is just, whatever. So this is what you do. Um, yeah. So that's the first lesson to learn from this is that it's okay if a letter equals a different number today than it did yesterday, or from problem to problem. The next cartoon, it's not really a cartoon, but it's just a little drawing of what we're doing here. So an equals is like a balance, it's like a balance beam, where things are the same on both sides. They're equal. They're at equal footings, or they're the same, whatever. So what we're going to do here is we're going to get rid of these three little washers. We get rid of the three over here. We cross those out, and we're left with the next thing. Whatever we do, basically what we're saying here is that whatever we do to one side, we have to do to the other. So if I cross out 3 over here, if I only cross them out on the left side, it would be imbalanced. This one would go up, and this one would go down. But we want to keep them the same. So whatever we do to this side, we have to do to this side too. Next one. This has 5 bags of washers, and this one has 2. So what we can do is we can actually take 2 of these and cross them out. But remember, if we do that over here, if we cross these out, then we have to cross them out over here too. Just, whatever we do to the left, we have to do to the right. And then our next one is, our last step is, if we have 3 bags and that equals 15, we can group these up, 1, 2, 3, 4, 5. We can group these up into groups of 5. And notice we'll have 3 bags and 3 bags. So 1 bag equals 5. That's a very visual representation of the kind of algebra stuff that we'll do for the problems for this section. As always, if you ever need to pause it, rewind it, listen to what I say again, feel free to do that. I wouldn't even know. It's the magic of computers. But yeah. So here are problems. Like I said before, if you ever need to pause it, if you're doing this for practice, please, once I show the problems, pause it, try them on your own, and then play it. See if you got the answers right. That's the idea. If you're doing this for review, you can just listen to me if you want, or practice. And then if you're absent, just listen along and copy down the notes. So here our first problem. There's a variable on one side. Remember, variable is a letter. What we're doing here is we're solving. When we're solving, we want to think of opposites. So remember, addition and subtraction are opposites. Remember that multiplying and dividing are opposites. Remember that reciprocals, multiplying by reciprocals, are opposites. So those are kind of the big opposites that we want to think of. When we're solving, always opposites. Opposites attract, or something like that. I don't know. Yeah. So here are our first problems. 3 equals 2p plus 5. So we're going to do, we want to get the p by itself. So we're kind of shedding back layers. We're unwrapping an onion. We're taking off pieces of lettuce. We're whatever other food analogy you want to do. So to get rid of the plus 5, because we want the p by itself, we subtract 5. But remember, from that balance thing, whatever you do to one side, we have to do to the other. So these cross out, so we get negative 2 equals 2p. This is multiplication. You remember the opposite of multiplication is division. So we got to divide. Whatever we do to one side, we have to do to the other. And that's our final answer, negative 1. It doesn't matter if the p is on the right or the left. The equal sign means that they're the same. Next one. Again, we want to get this b by itself. So first we got to get rid of the plus 5. Opposite of a plus 5 is a minus 5. So 3/11 b equals 0. Remember, reciprocals are opposites. So we multiply, instead of by 3/11, we multiply by 11/3. These cancel out. So our b is 0 times 11 over 3 is 0. So that's one side. Variable on one side. Pretty easy. Been doing that since 7th, 8th grade, something like that. Next problems. We have variables on two sides. So here, all we're doing, a lot of this happens so much with math. All we're doing is we're putting one step at the beginning. The rest of the problem is the exact same as the one we did before. So that's the real nice thing about these type of math problems, that one more step and then it's the same as what we just did before. So as long as it really builds on itself. As long as you get what's going up above, you can do these. So we want to get all of our letters on one side. That's that extra step. Once we get all the letters on the same side, we're fine. We're golden. We're the same at the top. So the opposite of a minus 4c is a plus 4c. So those go away. So we have 6c plus 14 equals 6. Hey, that looks extremely similar to the problems we did before. So it's all the same. So now we want to get our c by itself, so we subtract 14. And then we divide, because we're doing multiplication, so we want to do the opposite. We can reduce that fraction by dividing them both by 2. So our final answer is negative 4 over 3. That's it. So again, once we did this first step of getting all the letters on the same side, it's all the same. Everything here is the same as we just did. Yay. Next one, gotta get all the letters on the same side. Subtract 2w. Hey, that looks really similar to the ones we did right above on a page. So subtract 2. Again, we're peeling back the layers so we get that w by itself. We're always thinking about opposites like I listed up above. Subtraction and addition, multiplication and subtraction and addition, multiplication and division, reciprocals. Those are all really important. Oops. And we'll learn some more opposites later on this year, like exponents and roots, things like that. So we're not done yet with that sort of thing. So those are those problems. 2 more problems to go. Next one. Woo, lots of stuff going on in this. We remember from section 1.2, if you have parentheses, remember PEMDAS, or please excuse my dear Aunt Sally. At parentheses, you gotta do that first. You gotta distribute first. Now you look for like terms. So you can kind of write the steps along the side here. Distribute like terms. So 10w minus 4. This has a w and this has a w. So we combine those on the same side of the equals. Now, hey, this problem looks super similar to the ones we just did. Super duper similar. So it's all the same. So we gotta get the w's on the same side. So again, this is the cool part about the math stuff is you just add a couple more steps on, otherwise it's all the same. So here we go. We'll finish this up. 2w minus 4 equals 4. 2w equals 8. I added 4 to both sides. And w equals 4 after you divide by 2. I was running out of room. Sorry. It's a little crowded down there. So that's our answer. So if you're doing this as practice, that's the answer you got. One more problem. Dun dun dun! Fractions! Oh, everybody loves fractions. No, that's not true at all, but whatever. So when we see fractions, we think to ourselves, man, I don't like fractions very much. Or maybe, I mean, that's what I do anyway, and I'm a math teacher, so I can only imagine what other people think of fractions. What we want to do, though, is since we don't really like them, we want to get rid of them. Get those fractions out of here. So what we're going to do is we're going to divide by a number that'll get rid of the 7 and the 3. Those are on the bottom. So what's a number that can be divided evenly by 7 and 3? We think to ourselves. When we say self, I think it's 21. So what we're going to do is we can do this, we can multiply everything by the same number. And that'll get rid of all those fractions. Yeah, fractions. Blah. So what happens here is 21 divided by 7 is 3. So we have 3 times 4 times z. Well, I'll write this a little bit bigger. 3 times 4z. Because that 21 and 7 turned into 3. Here we'll have plus 7 times 2z. Because the 21 and the 3 combined into 7. 21 divided by 3. And lastly, we have 21 times 3. I'm not using a calculator right now, as far as you know. It's the magic of computers. I just used a calculator. 273. Now, remember, please excuse my dear Aunt Sally. We have multiplication going on, so we want to do that first. And we can combine like terms. And then we can divide. Because we are multiplying, and those are opposites. Now again, as far as you know, I'm not using a calculator. But I am using a calculator. And we get 10.5. That's our final answer. So that is section 1.3. Solving equations. We solved with one variable. We added a step by moving that variable over first, and then it was all the same. All of this stuff with the arrow next to it is all the same. Then we upgraded to doing the parentheses stuff, but then it's the same as what's up above, and then we ended with fractions. Whereas again, once we got to this spot right here, it's all the same as the problems we did above. So there you go. Good luck. Thanks.